Thank you, thank you.
Hello, hello everyone. It's been a long day for you. So this session aims to be a developer's guide in the AI-assisted era. My name is Konstantina Mavrodimitraki, and this is Dimitris Papageorgiou. We're both senior solutions architect working for Amazon Web Services here in Greece. Now, this session brings observations based on the discussions that we have with our customers, who are big IT companies. And let's check the agenda. OK, so first we're going to start with a discussion on the current state. We will see where we are right now in the AI adoption phase. And then we will proceed with a framework proposal. So more or less, we will see how we can propose a way that helps you integrate agentic AI into your development lifecycle. And then we will close with a few ideas on how to scale and implement this further. So what is the current state? So what we see right now, based on the discussions that we have with development teams in the last year, we see that a lot of companies are actually purchasing AI tools, AI tool licenses. They distribute it to their teams, and then they wait for magic to happen. What actually happens, what we see at least, is that a lot of developers working on their own, experimenting with different AI tools, without a structure, without common best practices, without following any guidelines. This has the following results. The teams do not have a common language that will help them identify if indeed these tools help them become faster. And actually, there is a name for this kind of pattern, let's say, and I'm pretty sure that everybody has heard of it by now. It's called vibe coding. So there are many challenges with vibe coding. We don't going to get into that. But when we are asking our customers, like how is, to bring us measures of the AI adoption, actual AI adoption, we get vague answers, like it feels faster, we haven't decided yet, we're playing around with different tools. So it's pretty vague. And if we consider that also in many occasions companies have invested in these tools, of course, there are also a lot of questions from leadership, like what's the return of investment here? So what's next? For sure, we're not going to convince you that AI is the future. And also, we're not going to cry over losing our jobs with AI. That's not what I'm going to do. We're going to propose, instead, a proven pragmatic framework that will help you integrate agentic AI systematically into your software development lifecycle in a structured way and with measurable results. So by the end of this session, you will have an implementation, a solution to move forward. Either you are a team leader with authority or a developer who is trying to convince their manager. But first, let's take a step back. Let's see what are the 5 phases of the software development lifecycle. So I'm pretty sure you know all these steps, but planning is very, very important. Here is where we need to search around documentation. We need to read the new requirements to see where the current architecture is, design the change. It sounds simple. It's not. Things do not move that linear and progressively, let's say. Then we have the coding phase. This is the creation phase. This is the most fun, let's say, part of the life cycle. This is where we are writing the code, we're managing the infrastructure. Many people think that this is where where developers spend most of their time. Actually, this is not true. We spend roughly 30% of our time with writing code. Then we have the necessary evil, I would say, the testing phase. So here we need to design proper testing strategies, write unit tests, check for security vulnerabilities. Operations, we need to hopefully identify and mitigate issues before they reach production. But of course, in general, monitoring and troubleshooting are a continuous and, let's be honest, vicious circle. And then we have the maintenance and modernization phase. So here we need to update old code. We need to update dependencies. And someone might ask, OK, now that we have AI in the picture, how can we make the software development lifecycle more efficient? And this is what the framework is going to discuss, basically, today. So what we see for sure is that successful AI adoption, it's not a linear progression of use cases, meaning that today I'm going to use AI for the planning phase, then I'm going to continue with writing code, then testing, etc. No. Successful AI adoption is about understanding two different dimensions at the same time. So as you will see in the vertical dimension, we have the pain points. So every team needs to understand what hurts the most. Is it code review bottlenecks? Is it testing gaps? Is it troubleshooting? Is it new development slowdowns? This is where each team needs to figure out for their use case. And of course, prioritize. And then on the horizontal axis, we have AI maturity. This is very also important. Every team needs to identify their level of readiness. This is not about how good the developers are or how smart. It's about how ready they are to integrate AI systematically into their life cycle. And these are the three levels of AI maturity. So the first one is individual experimentation. This is where most companies are right now. This is what we call vibe coding. Everyone is experimenting on their own using different tools, but there is not really a structure. Then we have the team standardization. At this point, the teams are, let's say, start to have a common language, right? A structure. What tools are we using? When are we using them? They are documenting these practices and sharing in the team. And then we have the cross-team integration. This is where AI practices scale across multiple teams, and the organization, let's say, is building capabilities. And this is basically where you reach the point where AI is embedded into how you systematically, let's say, ship code. And here's how the framework works. You need to work backwards from your pain points. So each team needs to identify their pain points. Then you need to assess your maturity level, and then you need to implement a solution which is appropriate to your level of readiness. For example, a team at level 1 facing code review bottlenecks needs a different approach than a team at level 2 facing the same issue. And also, keep in mind that I use the word implement, not adopt, right? This is because generic AI adoption is doomed to fail, because it doesn't take into consideration your maturity and what are your specific pain points. And now let's go through a specific pain point in order to see how this framework works in practice. And these are the code review bottlenecks. And I'm not, is this a familiar pain for many here? Okay, it seems to be a common issue. So you know the drill. We need to ship new features. The engineers are working on the code. When they're ready, they open a pull request. And then, well, the life of the developer happens. A lot of tasks in parallel, a lot of context switching. It takes time to actually do the code reviews. And in many cases, also quality suffers because people are rushed. So let's see how we can enhance that with AI. So at level 1, this is where we have the individual experimentation. So a team decides to use AI in order to help with code reviews. So at this point, the developers, the engineers start playing around with different tools. Maybe it's Copilot, maybe it's Cloud Code, maybe it's Kiro, Amazon Kiro. But at this point, things are relaxed and fun, no structure yet. What you really need to do here is create space for structured experimentation. So make sure to reserve appropriate time, maybe 2 weeks, for example, and ideally everybody in the team should participate. All the engineers should play around with different tools. And note that here we're using AI tools not to write code, but to review code. So we need to test things like different tools to check for security vulnerabilities, for whether these tools enforce coding standards or enforce style consistency, or check even whether the coding logic is, adheres to the business requirements, things like that. Now, at the end of this experimentation circle, you need to hold a retrospective. Every developer, every engineer needs to participate in that and present what tool they used, what worked, what didn't work, and any considerations that we need to think of. And for now, there are no metrics. Now, at this point, the retrospective has revealed a few patterns. And this is now the time for decisions, right? Some tools work better with security scanning, some tools are better to enforcing style consistency, and so on and so forth. But in general, this is where the actual work starts, and we need to take some decisions. Which tool are we going forward with? Maybe we're building a custom one using a framework, or do we need a human in the loop? Which code review tasks will the AI handle? Questions like that. It's very important we start putting structure now. So we need to document everything, right? So create a Confluence page, create a wiki page. This is not bureaucracy. This is important because it helps us not fall back to the vibe coding phase. So there, document your decision-making process, the tools that you are using, what is the evaluation methodology, any MCP tools that you want to use, all this information, plus the measures. Now we're starting to measure things. And you could measure stuff like time, average time from PR creation to PR approval, or number of reviews per cycle, per PR, let's say, and then, or the AI suggested acceptance rate. Now, this is an actual implementation on a code review workflow from a big AWS customer who's operating on the betting and gaming space. So if we go through the workflow, we'll see that when the engineer opens a pull request on their Git tool, this event flows through Kafka into the data analysis pipeline. Now, this is very important because the data analysis pipeline will enrich the context that we're pushing to our agent and to the model eventually. So here we need to gather information. We don't want to just push, the diff, what changed. We want to enrich this information with maybe repository structure, maybe naming conventions, any compliance requirements, repository information on the code base, on the project itself, on the feature. All this information, depending, of course, on the task, will trigger eventually the agent, who is built on top of Amazon Bedrock. And then the agent will review and post the comments directly to the engineer. Something that is not documented here is that there's also, in some cases, a human in the loop in order to validate the comments. Now, a strategic decision here, an architectural decision that the company took is that, and helped them actually move to level 3, is that instead of locking themselves with a specific model or vendor, instead they build their agent on Amazon Bedrock. And I'm not sure if everyone here knows what Amazon Bedrock is, but it is an AWS service that actually gives you access to a model marketplace, among other things. So this helped the company be very flexible and adopt and swap to new models. And of course, we know that new models come out very, very fast. But on top of that, Bedrock also gives us other capabilities like model evaluation or agent evaluation. And this is very important because right now we're introducing a new tool into our life cycle, and we need to maintain that tool. So Bedrock gives these capabilities that can help us do that. Now, at this point, we have an AI-assisted code review process that is working. Many other teams are asking questions, and the leadership wants to scale the success. And it's important here not to just roll out the tool to these teams, but instead you need to throw workshops, right? This is important because otherwise it's yet another tool in the life cycle. Instead, with the workshops, what you're doing is that the teams learn by doing, right? And they are able also to adjust the process to their own needs. Now, it's also here we are tracking also the adoption in an organization level. So how much time, for example, overall has been saved to the teams? How many teams moved from level 1 to level 2? Are the teams learning, sharing learnings and other information? These are some real metrics from the previous use case I was talking about the betting gaming customer. I would like to focus on the third metric. So more than 16,000 hours were returned to the engineers, and this is on an annual basis, by the way. So this is very important for the particular team because they're operating in the betting and gaming space, and it's a very competitive space. So the amount of new features coming out is, the speed is crazy. So that allowed them actually to use that time and shift the attention to business-critical paths. And these are the key takeaways. Start with experimentation. Allow yourself to build maturity on the tools and on AI, on the new technology. Standardize things within the team. Build a common language, and then scale further. Now, before I pass it on to Dimitris, another common pain point is testing, of course. So many teams struggle with testing coverage, testing maintenance, test creation speed. So let's go quickly how the framework would apply. So at level 1, the developers will experiment with different AI-generated unit tests. Then at level 2, we would establish some common guidelines. When are we using AI-generated unit tests versus when do we need the humans to do that? Measures, of course, and then at level 3, we are building a shared, across the organization, a shared test patterns and test-generated pipelines. And a while back, we were working with Dimitris on a project, and this is where we started using AI in order to test things out. So at this point, we had the service ready, and we used Amazon Q Developer in order to help us generate integration tests faster. We were really surprised, to be honest, because in a matter of a few minutes, we were able, just a quick prompt, it was able to catch the framework that we were using, what the service was doing, what we wanted to test, and it was amazing. I mean, in a couple of minutes, we had the unit test ready. We just had to do a few fixes here and there. It even created mock data, assertions, everything was ready, and we just had to validate the logic. So this was impressive for us. Pass it on to Dimitris to continue some coding pain points.
So there is this interesting study by software.com which they try to measure how many hours developers are actually using writing code. And they got these numbers. For me, sounds a bit pessimistic. How is this for you? Does that make sense? Are they too low? Are they too high? Usually, on average, I think it kind of makes sense. And it makes a lot of challenges. And this is happening because usually you need to debug some stuff, object monitoring, fixing some things in production, perhaps, or even discuss some requirement engineering and so on. So there's not a lot of time to start writing code in order to actually work on the most interesting part, let's say, of software development lifecycle, which is actually feature development. So feature development, of course, although it's quite interesting, you build something new, so you feel creative, you roll out something that makes use for your customers, you bring value to the company and so on, but it also has a couple of challenges, like every part of the software development lifecycle. And the first one of those, of course, the requirements. You need to discuss with the product team, product owner, product manager, business analyst, in order to understand what you actually are required to build. The second challenge, of course, is the issue triaging, management, prioritization, which feature has to be built first, how we are handling the defects, how many time are we going to reserve for the different defects and features, and so it can become quite challenging in order to focus your work on building the actual feature that you want to build. And finally, of course, it's the cross-team alignment, especially for large companies with a lot of teams. For instance, if you're working on SAFe, is anyone working here with a SAFe agile framework? Or usually it's a bit difficult to coordinate across different teams. Who has to build something? What are the dependencies? When this team has to build a specific feature for the other one to keep up and working. So it makes it a little bit of a challenge on how to build your feature. And this is actually where spec-driven development comes, which actually tries to tackle a little bit, to bring the AI in supporting of feature development, and moves a little bit further from what we call until now actually vibe coding. Because with spec beforehand, what we're working before with AI tools, it doesn't matter which tool, it might be Copilot, Cloud Code, or whatever, you just assign a specific task to the agent, write me a service, write me, fix me this, help me to fix this bug, write this test, and so on. So really a small task without the appropriate context, and moves one step further by giving a set of requirements to the agent, and will help you build a specific feature. So what it does more or less, it gives a kind of a context. So first of all, you can work with the agent in order to define the vision. So create as clear as possible requirements which you will feed to the agent in order for the tool to understand what you are trying to build. And also pushes you a bit to make the architectural decision as left as possible. And we were talking about architectural decision, it's technology, design. If we go, for instance, say which libraries or which other tools and existing frameworks are we going to use. So it gives you, it pushes you a bit beforehand and helps you also to have the design in order to be more confident at the beginning that what you are building is actually makes sense. And finally, it helps you implement with context. So instead of, as we mentioned before, yes, build this service for me, this API, help me build something and so on, you give an appropriate context to the agent who knows, okay, now what we're building a feature, and which might be, for instance, might be a search functionality, might be authentication, it doesn't matter. At least it knows that whatever commands or whatever task you are building is being used in order to have a specific goal. If we go now to the software development lifecycle, the 5 steps that we saw before, vibe coding more or less sits on the implementation phase. So if it's a part of a feature or a bug fix or whatever, usually you are working with the agent, can you help me this, identify this, build me this test, or fix this service, and so on. Now, spec-driven development has a broader footprint, let's say, because you work together with the agent in more parts of the software development lifecycle. In the beginning, from planning to implementation, testing, and deployment. So how can you use spec-driven development? So coincidentally, Amazon has rolled out this Kiro Agentic ID. Do you know Kiro? Have you heard about it? Have you used it? So Kiro is an agentic ID which actually pioneered spec-driven development. And what actually spec-driven development is this workflow. So it looks a bit complicated, but let's try to break it down a little bit. So how it starts, we start with the prompt to the agent. So you give the intent, which in that case is the feature that you want to build. We will see later on how this actually looks like in a simplified way, but as more detail you do, you better results you get from the agent. And by combining different steering documents where you give some instructions, for instance, or specific hooks, or for instance, how some architecture decisions have been made across the company, it gets this information, it creates an opinionated workflow, which is consisted of 2 steps. The first one, it actually consists of 3 parts, which the first one is the requirements. So he gets the feature and starts building the requirements, which is more or less a user stories. So it creates these requirements. As a user, I want to do this, this, and that. And you also get the appropriate acceptance criteria. But as soon as you get that from the tool, this doesn't mean that that's it and you don't do anything like that, and you don't do anything more. You could keep working with the agent, discussing, removing things, updating. So it's kind of bi-directional communication. As soon as you're OK with the requirements, move to the design phase, which is the architectural part of the solution. So what are we testing? Parts of unit testing, integration, UI testing, what will be the communication, if it's going to be, for instance, synchronous or asynchronous, some nice architecture diagrams. You could even integrate some MCP server to get a diagram for your Confluence web page and so on. So you build the architecture of the feature that you are building. So for a small feature, it might sound a bit overkill, but if you start building from scratch, like larger features and complex stuff, it can be very helpful. And as soon as it is ready, we have the task phase where the different requirements are being split in different tasks. And this is actually now where you could start distributing across the team and start working across during, for instance, the life cycle of a sprint. So here, of course, you could leave the agent build this stuff by itself, but it's not something that I would recommend because I think it's quite important having software engineers working together with AI tool, because I think by having AI tools working by themselves, it's going to create a lot of technical debts. As soon as this phase is ready, then we move to the implementation and testing. It's quite straightforward. You get the tasks, implement them, roll out to QA, get some bugs, fix them, go back if you need to revamp, for instance, requirements or tasks and so on, implement, and as soon as you are ready, then you are ready to roll it out to production, do the deployment, and then maintain the feature or the application that you are building. So from a look and feel perspective, how it looks like, for instance, with Kiro, you have this, it's based on VS Code, so it's quite similar. I know it's not IntelliJ, okay, but still it's quite useful and helpful, I have to say. And how it looks like, you start this spec-driven development lifecycle, and you say, yes, I want to add a new feature, which in that case, it's categories for events, let's say, and also be able to filter on that. So how does it work? The agent now will get this information, which is the context that we're giving in the beginning, like the prompt and the intent for the agent to start working on that. And then it will also read our code base, the repo in that case that we are working. We start building the requirements. So as you can see, it's similar to a user story. So as an event organizer, I want to create and manage event categories and so on. And you're also getting the acceptance criteria, you know, kind of a definition of done. Of course, as we mentioned before, you could start also working on that, and if you want to remove some things, add some other things, or update something. So it's kind of sprint planning, let's say. And then as soon as you are ready, you move to the design phase where you have the architectural decision. So which test are you going to use? So in that case, it's a Python project. So it gives you some code snippets also. If you want to have synchronous communication, REST APIs, you also define them here. Or if you want to have, for instance, asynchronous communication with a Kafka topics or RabbitMQ and so on, all these things are being defined to this part. And then finally, we are moving to the task. As you can see here is a task the breakdown of the requirements. So it goes step by step, plus also the dependencies. So you need so you are aware that which task has to be implemented beforehand, so not to disrupt the whole life cycle. And then now actually you are ready to start implementing. So if you could have, for instance, an MCP, I don't know, with the Atlassian, for instance, you could have also updated your Jira board for your dailies and your stand-ups. So you could start working as a team to implement this feature. So how you could integrate it based on the framework that we discussed already beforehand. Let's say that we are on the first step, so we need to start experimenting a bit. So a very good example and good candidate for this one is kind of what we call sometimes technical stories. I know that the term is not ideal, but usually stories which do not involve a lot of business stakeholders. So mostly relate architectural decisions, for instance, an upgrade, which database are we going to use, if we need, for instance, to migrate from REST APIs to asynchronous communication. So usually stories which based solely on technology. In that case, then a couple of engineers will start working on that. Spec-driven development will give the intent, requirements, design, task, and they start working on that. As soon as they're done, of course, we had the phase which is called the retro. Then they need to start thinking, so, okay, we use spec-driven development, we roll it out to production. What does it mean exactly? Did we get anything better? Did we get anything worse? What makes sense? For instance, was it faster rolling it out to production? Did we avoid having any back and forth while we're implementing it? By setting concrete metrics, it will give the opportunity to identify, yes, what we are using and how we are using it actually brings value. Because, yes, AI, it's important. Everyone wants to use it. But at the end of the day, at least from my point of view, it's kind of a tool. So we are using it in order to fix actual problems that we're facing during our everyday tasks, for instance. To make it more interesting, then we need to scale this thing. Now, in that case, now we're not going to scale it only horizontally, but also vertically, because it makes sense to integrate also people from the product. So product owners, product designers, business analysts, and so on. And instead of working solely on technical stories isolated from the business, now it's a good starting point, for instance, during a sprint planning, where we had the discussion about which stories or which features will be implemented, work together as a team, both product and engineering team, and start work on a story on a spec-driven development approach. So instead of writing the stories in Jira boards and actually trying to identify what's missing and so on, using all this conversation and communication and collaboration to get together with the agent in a spec-driven development approach to get the requirements in collaboration with the agent. Use it during the sprint planning. Instead of updating Jira, work on the spec-driven with the agent and start having the requirements, design, tasks, and then start working. The team will start working on the different task assignment. Also important to have some metrics here. I mean, the North Star of the metrics, quite simply, it's how fast we are rolling out and how many bugs are we having. If you want to keep things simple, then you could have this metrics. But perhaps it makes more sense to keep a little bit more granular approach. So, for instance, how many back and forth did we have as soon as we thought that, yes, the story is ready to be implemented, because it's quite common issue that we're facing while we're working, especially in the large companies with many different engineering teams and many different business stakeholders. So think about which are the issues that we're facing while you're rolling out feature and try to put some metrics that tackle exactly this feature. So we saw different pain points here. We saw different specific approach, which is not based on tool, because there are thousands of tools outside. We saw also a use case where you could build your own tool. We had like a customer building actually this tool, having the code reviews. I didn't use any of those. But anyhow, the important thing here is that team that try to integrate AI in the software development lifecycle take out 4 takeaways. First of all, they're becoming very good in evaluating AI. A lot of different tools, approaches, and so on. It's important to keep a critical view and aspect and thought of what you are trying to use, and always keep in mind to use this, the appropriate tool, let's say, that tackles exactly the problem that each team is facing. It will also help the team to establish team-wide practices, because, for instance, if one person is using Cloud Code, the other one is using Codex, the other one is just throwing code to ChatGPT, this makes things quite more complicated. And especially that we have an order of magnitude increase of code generation from AI tools, this makes it even more complicated to understand what's happening and creates way more technical depth. So if a team establishes a team-wide practice and everyone is working in a similar way, then it makes things way more simple and it helps the team move forward by integrating different specific AI tools. They are becoming very good by measuring impact. This is actually a very good point, not only by the AI integration, I think it's a very good point also for your career. Because let's be honest, no one cares how clean is your code, how many tests you have written, or if you are using super cool patterns. Usually people are interested for things, okay, what did you roll out? What feature did you roll out? What was the value of this feature bringing to the company? How did we improve the experience of our user? So it gives you a bit of a perspective on moving a little bit higher than simply writing software and engineering things. It gives you also a perspective on what matters for the business and the company. And finally, build trust, because you need to trust a tool which works with you in order to implement something. It also builds trust within the team, because it's a whole process which has a lot of discussions and back and forth across the different members of the team, and then I think improves the collaboration across the different teams and people. So how to scale and implement this framework, I think usually depends on the role. I'm not a big fan of having roles like technical leads, architects, engineers. I'm more of a fan of a flat hierarchy, let's say. But still, usually for technical leads, if you are responsible for a couple of teams for architecture decision, then you have to follow these following steps in order to make the AI adoption quite successful for your company. First of all, it's not like you don't have to treat it as a side project. You need to have an epic, a story, a feature, something to the backlog that, yes, now we will try to adopt AI and see what makes sense for our use case. First, also, not only have the epic on the backlog, you also need to reserve some time for experimentation, some story points in sprint, a couple of days, weeks, it doesn't matter. You need to have the team working on that, and not like as a hobby project, but also keeping a definition of done of what you are trying to integrate, because at the end of the day, you need to have a decision about what you are going to use, how you are going to use it, and how the team will integrate in the software development lifecycle. Because usually, if you don't have metrics and you don't have ownership, it can be easily digress, and at the end of the day, you might not get any concrete results. From a software engineer perspective, for not team leaders here, you have to be more vocal. By talking about more vocal, first of all, share the metrics that you have. So if you are using a tool, what actually you are tackling with this tool, what it brings better, how it improves your whole experience. Keep actually concrete metrics, because it will help you justify your decision. Be more vocal, because you're going to have a lot of objections within the team, because, for instance, they might have different requirements, different expectations from the tool. Take this feedback, this constructive feedback, and try to work around this in order to make the adoption good for everyone, not only for yourself, because at the end of the day, a whole team or a whole company will start working on this. And finally, organize a workshop or retro, make it fun, perhaps in a hackathon style of thing, showcase to the other team and the other teams what you actually did, how you did it, let them play around, give them the opportunity also to experiment in order to build something that makes sense for everyone. Common pitfalls to avoid, of course, we discussed about the framework. If you don't have a structured approach, it's not going to work out, because things are going to be quite complicated, quite messy. At the end of the day, you're not going to get any value there, and you're not having any clear metrics. As we mentioned before, measure everything, keep track of what you are doing, what you are improving. It will help you and the whole team, and even the higher C-level executives, whatever, will give you quite a lot of ammunition to justify this adoption and persuade everyone to start working towards the adoption. It's important to have ownership. Ownership and accountability is very important, because then someone needs to be responsible for what you are working on, and actually, at the end of the day, he will take care of the project. That, yes, we use this tool, we improve these things, and I think if we use like that, it will improve our whole everyday task and experience. And actually use a divide and conquer approach. Pick a specific pain point as a beginning that your team is facing. Might be code reviews, might be testing, might be feature development, and start working backwards from this one, in order, first of all, to use the appropriate tool for the use case, and to integrate it as smooth as possible in order to bring actual value to the team. So, we're closing our session today with a saying. So, the one who gathers many tools but lacks right practice builds nothing, and he who walks step by step builds a strong house. And this is a ChatGPT interpretation of Confucius, if he was living nowadays. So thank you very much. I hope you enjoyed it, and we're here for any questions and discussions. Thank you.